morning. The doors are closed, we're sold out. This is our second pancake breakfast of the week. My name is Alex Williams. I'm founder and editor-in-chief of the New Stack. We do these pancake breakfasts at KubeCon events and other events around the world. And we could not do them without our sponsors. And so I want to thank VMware for sponsoring this breakfast this morning. Let's give them a big hand. Joining me in co-hosting the event today is Libby Clark, our editorial director. She has the mic, and so when we start asking questions, she'll be there to provide the mic for what you might ask. One of the things that we like to do with these pancake breakfasts is make them a real question and answer opportunity for you to ask questions, to make it interactive and create some dialogue here. To do that, you each have your tickets. Did everyone get a raffle ticket? If you didn't, raise your hand. Okay, we have one raffle ticket over here that's needed. Oh, you got it. Oh, you got it. Okay. Does everyone has a raffle ticket? Excellent. So here's the deal. If you ask a question, you get 5 extra raffle tickets. And the prize is an Arduino. And that's just how it goes. And so feel free to ask your questions, and we'll give you those extra tickets, and you'll get a chance to win in the drawing. Service mesh is a topic that consistently draws interest on the New Stack. We see the topic being discussed over and over and over again in the stories that we write, in the podcasts that we publish. And I'm curious about it because it's quite an abstraction, and it leads to a lot of questions, about how we think about our infrastructure overall. So that's really going to be the focus, I think, of our discussion today. And so I just want to introduce our speakers. We have Cliff Grossner, Edie Levine, Per Monclou, and Fabian Florian. And let me just get that right again, Florian, so it'll come up. There we are. Make sure I pronounce your name right. Florian Dudouet from Swisscom. And Edie Levine, we're all here. So thank you very much for joining us on this panel discussion. I want to just get started to ask you all a question about what is networking anyway these days. With service mesh technologies, we're starting to ask these questions, and I know that you're probably thinking about these questions quite a bit yourself. So maybe, Cliff, you could get started with that, because you're the one actually who suggested that, and so I'd love to get your thoughts.
Okay, sure. Well, I think the way I look at it is, having been in networking for many, many years, is service mesh is a chance for us to rethink how we should be doing networking. And I don't want to imply that we didn't do it right the first time, but we did it right. We did it that way because of a particular time in the world where applications were monolithic. We were very device-centric, and it served us well. However, today, applications aren't monolithic as we move forward with cloud-native architectures. And it seems to me a lot of the structures that we put in place to do networking need to be rethought.
Okay. Edie?
Yeah. So I think like everything that's happening in this ecosystem, we started in the beginning with the hardware. That's where we were until now. But what we're trying to do right now is talk about application. In the end of the day, that's what we care of. And I think that service mesh is exactly doing this. Instead of talking about hardware, instead of talking about layers, what we're talking about is the services, right, or the application. And I think that that will be the most interesting place to talk anyway, because in the end of the day, that's what we care. We're running application.
Right. So that's the evolution, right? So right. We're thinking now increasingly about services.
Right. So we kind of like ignoring, and this is what's happening with everything, right? With serverless, right. Or with everything that we're doing, we kind of like bring it up to the application level. I think that's what serverless is doing. service mesh is doing.
Per?
Maybe the thing that has happened the last few years is that originally networking was an infrastructure layer that you would create ahead of time. So you would think in terms of compute, storage, networking, regardless of what type of applications you would create on top. And suddenly we went to the opposite thing, which is networking is just a service to assist the application to provide secure connectivity. So the biggest change is not necessarily that went from hardware to software or from infrastructure to application, but is this notion that network became something that you have to create on demand in a way that you fulfill the needs from the application point of view. And this is the aspect that now you start thinking, how do I serve better the application? And as you go up the stack, as you get into microservices, API gateways, and so on, now the meaning of networking starts to change because instead of identity being an IP address, now identity maybe is something a little bit more abstract, like a certificate or a stronger identity. Connectivity becomes something else, like security becomes something else. But as Edith was saying, is this notion that now it's not just an infrastructure layer that has to be there before you understand what application is going to be on top, but networking is going to start serving the needs of the application in a much more dynamic way.
With all the Kubernetes clusters that we've deployed either internally or for external customers, something which comes to mind when they think about service mesh is programmability and also avoiding the need to know what is the underlying network. So they don't have to know about routers, switches, or anything. They just think about services and linking things together and applying policies. And that's a big change from previous networking, where you really had to know all the internal details and how it works. And yeah, that's something that's really, really an evolution from before.
So Lee, for you, your thoughts on networking? I mean, you've been in the networking space for a long time, and you've seen this transformation. You are a Docker captain still, aren't you?
Yeah.
And so you've seen the container ecosystem really grow out. And what has happened to the concept of networking in the process for you?
Yeah, I'm glad that you brought up containers, because I think that's an interesting reflection and makes it maybe easier to understand what's happening with the proliferation of services. If we step back, one step back before containers, and we were dealing with VMs and VM sprawl, you think about, actually, if you step back even further to physical machines, they might have had 4, maybe 8 physical NICs. You could assign, virtual IP addresses to those. So maybe, I don't know, maybe 20 if you were maxing it out, sort of IP addresses, endpoints on the network. That maybe that many services that you would be hosting off of a physical node. You move over to a VM, you might take that times 4. You got a bunch of, up to 15 to 20 VMs, a bunch of different virtual interfaces there. Containers, then 100-something containers per server potentially, times that many. So it just gets more. Then you bring in services, and you've got some of the same concerns. You've got services sprawl. As you get into microservices, you end up, if you're doing something very meaningful, you end up moving pretty quickly, bringing forward quite a few more services. And so you need, with each of those layers, new tooling has been brought forth to manage a lot of the same concerns. So the service mesh, it's nuanced, but it reincarnates a lot of concepts that we've known kind of all along. It's just a different type of tooling. It's treating services as a first-class citizen on the network. It's about creating new networks in a programmatically controllable way, in a declarative way, having control over the network in that way, making sure that your network is really there concerned about your services.
So, yeah, go ahead.
Yeah, I actually just wanted to add one more thing. There's also pitfalls that we need to watch out for, because sometimes we can use a word like a service and think that we've changed the world. Well, in fact, TCP is a service, and it's embedded in the OS, and all programs since the beginning, well, for many, many years, use TCP as a service to do network connectivity. The real difference from my perspective is the level of abstraction that the service provides, hiding the complexity of the underlying implementation and also allowing programmability. So we've got to be real careful, just because we use a word, to think that we made a change.
So Edie, in this reincarnation, what are some of the use cases that you're starting to see emerge?
Yeah, so I think that like everything we're doing in this ecosystem, we're starting solving problem. Like for instance, moving from monolithic to microservices, and then we open a lot of more problem to the user. So I think that's exactly what happened in this evolution. Everybody got very excited about microservices. They wanted to move, but now they need to solve problems like how do you communicate between those microservices? How do you make sure that it's securely communicated? And the last one is how do you make sure that you actually can see what's going on in your cluster? And that's basically the third main problem that Service Mesh is trying to solve right now. So what I'm more passionate about is the way it's solving it and the opportunity that we are getting from it. So basically by abstracting and taking the operation code from actually the application itself. Before you needed to import a library and now it's all configurable on the sidecar. I think now we basically abstract the network. And if we really abstract the network from the business code, now there is a lot of stuff that we can do. And I think will be the most interesting thing that's happening in Service Mesh in this ecosystem for the next year or two.
Per, what are the use cases for organizations that already have like such, years and years of investment in existing infrastructure around their network?
Yes. Maybe what we see is that a lot of people don't necessarily start thinking that Service Mesh is networking. I mean, a lot of people start thinking, well, I'm a developer, I can put Istio and Envoy, I can instrument my application, I can understand what's going on, latencies, I can predict that this specific pod has a problem. So what we saw is a lot of people started by observability and understanding what's going on. Once you start by the observability, then immediately you start thinking, can I do something more interesting? Could I do like progressive rollouts, upgrades, blue-green testing, and so on? So what we saw is that it's much more like close to a DevOps tool, like the understanding of how do I tie my processes in terms of application deployment, upgrades, constant monitoring of SLIs, SLOs with Service Mesh. So I would not say that the first thing that comes to everybody in mind is, oh, this is a networking tool. It's much more. It's like a development operations tool that allows you to maintain your applications. And then immediately you start going to the point of saying, well, if I can understand what application is doing with what data or what authenticated user is coming to this and I can track the token and can have a tracing end-to-end, then you start thinking in terms of advanced uses of security. So I think sometimes we oversimplify because the fact that, of course, it provides connectivity with MTLS and distributed load balancing and all these things. But the reason why it's powerful is not just because it provides connectivity and load balancing and so on, is because it allows you to tie processes in terms of operations and security that are much more advanced than what could be done in different layers. And this is what we see. It's not necessarily, oh, this is a networking technology. It's much more than that.
It's much more. As everything is these days, right?
Yes, it's tough to go after Pele because he says everything that you need to say about service meshes. Everything is a little bit more. So the thing that these days I see in service meshes is that everyone sees about policy management, and every talk I've been to about service meshes, people have asked, what about the scalability of this thing? So, of course, it's the easy question, but it's a little bit overlooked by the community today. It's much more, and as he says, we have to remember it's still a networking tool, so all these things are full of proxies and everything. You have to take care that you are not putting your application like at a huge risk with a service mesh. It's not so simple as just putting it on and putting some policies and off you go in production. And I think the moving from nice POCs to the production is something that a lot of people in this room are probably struggling with as well.
Aha, and that leads to the time for questions. And here we have the Arduino. And so Libby Clark has the mic. My question, first of all, to everyone is, who's actually using Service Mesh in production right now? You raise your hand. Okay. Keep your hands raised, please. Who's testing it? And everyone else is kicking the tires, huh? So if you raise your hand and you're using it in production, you raise your hand if you're using it in production? Could you tell us some of the things that you're finding? We have Libby Clark. If you could maybe talk about some of the problems you're facing and really the reasons why you've decided to put it into production yourself.
Is this on?
Yes. So our primary concern was mutual encryption between services to ensure zero trust, basically, within our clusters, as well as telemetry. So we are building platforms for developers and product teams, and we cannot always, or we can't assume that they have instrumented their applications in such a way that we know what's actually going on and if the cluster is working. So that was our primary concerns.
Facing.
Since we have started using the challenges.
Yeah.
Yeah. Well, it's another layer of abstraction. it's another whole new area of things going wrong, and IP addresses, and yeah. So it's a new, completely new area to debug when it stops.
So it's a debug issue then?
Yeah.
Okay. So anyone else using it in production? Who would care to comment on kind of some of the challenges they're facing? You'll get tickets. Who's testing it by, oh, there's one person in the back. There's a person in the back here. Raise your hand, please, again.
Hello. Hello. Yeah, we use Istio in production, and our main concern is like stability of the project itself. It's quite new, and sometimes we see it's difficult to find problems in the logs of the application, and sometimes when things fail within Istio itself, it's a big concern because it's the main networking solution for the whole application. So if that fails, then everything fails. So it feels like one sort of choke point for the whole app.
So what is the problem that you're trying to solve, though, with Service Mesh?
I think the main thing for me was the telemetry. Like with a lot of services, it's really nice that you can sort of get a nice overview of everything and how networking works on the whole system. Like with a lot of teams working on a lot of services, you don't necessarily know about the whole application, and you get a lot of nice visual solutions that show you the whole network and allow more people to get more insights about how does their application work within the system.
So how do these issues align with what you're seeing, you know,
I
with
think
users?
there's it's, if you're listening closely, I think, and Edith may have kind of kicked off part of this thread that you're hearing, is there's some softer things that are enabled through Service Mesh. There is some empowerment, at least of the two respondents here. I'm guessing you're probably more on the platform team, a bit more in operations. You're probably enabled and feel a sigh of relief when the blindfold comes off and you get to see what's happening within your environment, when you don't have to rely on those pesky developers to actually, instrument code. Service meshes get me excited, so hey,
he's an advanced, he's an advanced panelist. He brings up his coffee, but
yeah, it's a self-serve. It's a, but that's I think that's actually key, and I've written about that in a recent book that I published. It talks about, well, actually, if you were to ask this question, I think, speaking of being interactive, if we were to say, within your environment, if you were to think about who is it that's responsible for rate limiting, service request calls to your application, or who is it that's responsible for exposing that telemetry? Is that the developer? Is that the operator? Is that someone else? I think you'd find that there's different responses based on organizational differences. And I think one of the really interesting things that Service Mesh does is brings forth a new layer of tooling. I would say at layer 5, a bit tongue-in-cheek, but to eliminate the diffusion of that responsibility, to bring forth a new set of controls where you can declaratively define how it is that you want for that network to work, what telemetry you're looking to get out, at what sampling rate you'd like to see it. So there's a thread here.
Per, and what are you finding in your own internal development, some of the challenges you're facing and some of the ways that you're using it that are providing that new level of tooling that Lee described?
Yeah, I mean, one aspect is what Lee is describing, which is the strength and the weakness, right? The fact that you have this new layer that now is the bridge between the developers and the platform teams, this is very powerful, but at the same time, in the absence of being very well understood, then you have the infrastructure team, the platform team, and the developer, that they all understand that Service Mesh has something for them, but now who's going to take the lead? So a lot of times what we see is if you talk to a team, an enterprise, that they understand the technology, they know what it does, then it's a very easy discussion. But when it's in the early stages, the question is, who's going to lead this discussion? Who's going to own that layer? Who's going to operate that layer? Who has the expertise to understand a little bit of what the application developers are doing and how the infrastructure works? And this is kind of these platform teams. I mean, Florian is one example, that it's a scarce resource. It's not that everybody, every single company have those skills to kind of cross layers. And if you are stuck between a development team and an infrastructure team, then it may be in no man's land. And what we're seeing is that as the level of awareness of what the platform means, especially when we get into Kubernetes and cloud native increases, it becomes easier. But right now, the fact that this layer, as Lee was saying, is kind of the cornerstone of talking to everybody, it's a problem by itself if you don't understand who is supposed to own it. And maybe Florian can elaborate more in terms of how you came to be and how you own those layers, because that's kind of the essence of who's going to have the skills to operate that type of infrastructure.
So as a service provider, you're often told by the customer, we want a service mesh. And then they want us to operate the service mesh, and then they want to have full admin powers to do whatever they want with it. So that's kind of a conflict inherent to this dichotomy where basically they have full control, but they still want you to manage the thing. And so that's one thing you have to really think about, how you organize yourself and your teams. So who owns and who operates, and who has access and modification rights. And it's also a problem of, but something we often have is questions on governance. So lots of enterprise we have as customers are like, typically have some governance that they want to put for every project. And we give them admin and they have to do an airbag model, and they don't know how to accompany their own customers, because usually we speak to IT teams who then delegate to different end users. And these people are not necessarily able to understand or like don't have the know-how, as Pierre was saying, to properly separate and have some common framework for all the namespaces or Kubernetes clusters that they have.
So Edie, what are the problems that you are seeing solved? I mean, is it that visibility? Is it that new level of tooling? And what are some of the deal breakers for you that you've seen as you've seen these architectures develop?
I think that the problem that I see right now is mainly the maturity of the tools. So I mean, there's a lot of service mesh out there. I think the reason there is a lot of them is that there's no clear winner yet. We don't know who is the one that's doing the best. What I'm very excited about is where it's going to. So I don't know if you heard about what Istio is doing in order to make WebAssembly working with Istio. I think that will make performance huge advantage that will make us use it better. I think that this distributed, like there is so much options there, but the customer itself need to kick the tire by himself. They don't know which one to choose. It's a huge problem. I think that's the problem that the SMIs tried to fix yesterday. So I think
the service mesh interface was the announcement,
service mesh interface that was announced by Microsoft and Ashi and Buoyant and us yesterday. That was exactly the problem that we tried to solve. Which API are you using, the difference between the implementation, and a lot of the problem and like the way to debug it will be a huge problem. I agree with all those abstraction layer. So there is a lot, and we need more to do. But I'm excited. Specifically with the provider, I think that HashiCorp is doing a huge investment and doing very well. Istio, AWS.
So what questions do you have about service mesh? We have one right here.
Good morning. Related to the first question you posed to the panel. So I was talking yesterday to somebody about how service mesh at least partially came from limitation of the classical TCP/IP stack, and more specifically layer 1 to 4. And I was thinking, how would service mesh look like if, for example, IPv6 was ubiquitous, was 100% adopted, and we had things like basically unlimited addresses. We had a flat network for containers and nodes. We can use their discovery protocols, maybe multicast and other things that IPv6 would provide. Would we need all of these, let's say, hacks of proxying? Could we use IP tables instead of having BPF filters, as we found out yesterday? How would that look? Thank you.
Wouldn't that be nice? We had some.
Go ahead, Per, and then we'll go to you, Lee.
So maybe there's two aspects to the question, right? One is, if we had IPv6 universe where everybody talks to everybody in a flat wall, definitely lots of things could be simplified, right? And you have initiatives like Beyond Corp and things like that where we could change the paradigm. The problem is always not that would be nice to have something like that, is that today's enterprises, they don't open all their IP addresses to the internet. They have private IP address space, they have firewalls, they have policies, they have perimeters. And now the thing is, when we start injecting a new technology like Kubernetes and putting it in an enterprise environment, you go to a financial institution and you tell them, yeah, don't worry, you're going to have a Kubernetes environment on-prem where all your pods that get dynamically created are going to openly talk to services that you have in Google or Amazon, or to cell phones connecting from any part of the world, right? And 99.99999% of the enterprise will say, are you nuts? So what happens is that we can design and think in terms of what type of technologies could simplify the infrastructure, but the truth is that we are going to live in a brownfield world, and we'll have to find a way in on how to bring service mesh and how to bring Kubernetes into the existing enterprise environments. And that's why there's a lot of complexity to connect an Oracle database on the heart of an organization to a microservices in a public cloud environment. And we'll have to continue to use new tools and old tools, because it's a kind of a continuum, not just a new flat universe. But it would be nice that one day we arrive to what you're saying.
Lee?
Yeah, like Per said, there's a very long tail of IT. It's a lot of psychological barriers to overcome as well, outside of grokking technology and bringing forth new technology and adopting that. There's some identities and roles and responsibilities that get shifted around. People get concerned. But to the question that might win an Arduino, which I have a question later as well.
Nope.
Okay. I love the multicast example. Little IGMP running around would be great. I think that my direct answer, if the world was IPv6, that you'd probably find that a service mesh is critically needed. That you really need the fine-grained traffic control, the end point itself, all the way to that service itself, security, identity, the rotation of certificates. That visibility becomes even more of a need. I think that you'd find service meshes would be very prominently needed in that case.
And IPv6 is just a way to plumb stuff together, right? You still need the traffic shaping, everything, all the policy control from Istio or whatever, service mesh would still be important, even if in that ideal world.
Question?
And maybe just one comment on this.
Sure.
I work in security in my past, right? So you have things like Spectre and Meltdown, and attacks that even if you have service mesh, they will not be contained. So that's why when you think in terms of security, even if on an idealistic way, a new technology could address all the connectivity and security problems you may have, because certain vulnerable components of your infrastructure, you may always have to resort to multiple layers of security, even if they are inconvenient, because there's a trade-off that you have to have.
Question?
Yeah. Good morning, all. My question is to Per Manklos. I see when we bring programming abilities to the network layer in the services, already I see a lot of complexities, example NSXT, NSXV. So for the new people, it adds more complex. So is there a way we can simplify the serviceability in the networking layer?
Libby,
or any best practices?
Did you guys get that? Here, Libby.
How do you make it easier for developers or anyone who's operating to interface with the service mesh?
I'll take this. Yeah, so NSX is an SDN layer, a network virtualization layer that offers you distributed switching, distributed routing, load balancing, firewalls, and so on. When you go at the service mesh level, now you have a new set of controls. And what we are doing is how to align the policy from one layer to the next in a way that, imagine that you have a microsegmentation policy at layer 4, should not contradict what you are putting at the layer 7 with the service mesh. And then you have things like ingress, egress envoys that they may have to be tainted by the microsegmentation groups of the layer 4 because otherwise you may have conflicting policies. So what we are doing is align the different layers in terms of groups, in terms of identities, in terms of policies, in a way that the operational model is consistent between the multiple layers.
Yeah, and what I'd like to add to that is, as we move up the layers, we have to make sure that one layer each layer is independent. So we can change, at, say, a layer 6 or a layer 7, and have the freedom for the application developer to set the policies they need at the application layer and have that filter down. And each layer should also be removable and changeable as needed, so that as we can make changes at one layer without impacting all layers, so we don't have an integrated stack. We have the ability to manage the system overall and at different levels. So the IT individual for the shared part of the infrastructure, because you will have to have shared infrastructure to go cross-cloud, to even grow between developers. You can't have you're not going to be able to have just one type of service mesh. And we need all those flexibilities to make it work.
Are there any people who have any security questions? I'd be curious on your questions about security of service mesh technologies.
Or performance questions?
Performance question. Anyone have questions about performance and with service mesh? No? Any other questions people have? There's one right here. Oh, we have one there.
So I'm curious. Yesterday during the keynote, they mentioned about the service mesh interface that was introduced. How does that affect some of these conversations that we're having right now?
I'll answer that. So I mean, it's another abstraction, which is always a problem, right? It's another abstraction. Before that, you had a problem of how do you debug, when you have Envoy and you have Istio, and now you have SMI as well. So this adapter is costing you. I think the adventure that I see with this, and I came with this idea, is because if you think about it, right now as an organization, in my opinion, you will need to run more than one mesh. Because you don't know, right? When we talked to our customer, they were debating, and therefore they were trying with a lot of type of service mesh. They needed to learn a new API. They needed to start operate with that. They needed to investigate that. That took quite a lot of time. And second of all, they also wasn't clear about which one to choose. And what if they choose Linkerd, but then Istio is the winner? So that's it. So the point is that way you can actually swap the implementation behind the scene, but it didn't change the layer on top of it. So every abstraction layer. Me specifically, the reason I was very engaged with that is because, as I said, in organization you will have more, at least, maybe the same type. Maybe you will use Istio. You will use more than one instance of Istio, right? Because you have more cluster. This is where we're going with, right? We don't want one big cluster. Multi-tenant, we kind of like want a small one. And guess what? Each of them will need a service mesh that you will need to manage, that you will, maybe will be different version. Maybe you have different organization inside your company that choose different service mesh. And maybe you want to go to AWS, and you know what? If so, you need to use AppMesh because it's free and it's integrated with everything you have there. So now the question is, how do you actually manage that? And this is an orchestration problem. And this is where I think we're going with SMI. So we have a product, Superglue, that SMI is basically based on. And basically what it's doing is exactly this. It's discovering every service mesh that you have. It's installing them, and then it's basically grouping them. I have this service mesh and this service mesh. I want to group them and use the same Prometheus, the same certificate. And for that, you need that layer. You need a layer of this abstraction because it's giving you more powerful. So I think this is like the main piece. And besides that, now we can start building as a community stuff on top of it. Because, as I said, service mesh is more than these 3 use cases. We specifically has this, like one of the products that we have is the ability to basically, because you're using Sidecar, actually recording everything that's happening in your production And once in the end of the transaction, if everything is good, we're just tossing it. But if not, we're kind of like saving it and let you replay that outside the production environment. This is a use case that we couldn't do before, right? So I think the ability to do that kind of this or chaos engineering, right? This is another thing that you probably make more sense on the layer of the proxy than actually embedded it in your code. So I think there's so much stuff we can do right now as a community. You saw yesterday Flagger and others, and I think that's where it would be very interesting. What is the use case that you as a company wanted to create?
Yeah, there really is so much more than kind of the three use cases that are prominently talked about service meshes. Edith and team are exploring and providing for some of those. There are even more I would expect to come forth. The nice thing about SMI, back to your question, is that, well, it facilitates a few things. Maybe some common nomenclature across service meshes such that we can have more easier conversations without a bunch of caveats. We're not confused about what we mean when we say a certain term. That's kind of nice. It also helps vendors and users refine the core use cases, refine the specification about how we collectively would generally like to interact with service meshes and speak to them and control them. So a common spec. Really, when you think about a common spec, a common API, there are some very close sibling examples of these. So if you're familiar with CNI, Container Networking Interface, CRI, Container Runtime Interface, CSI, Container Storage Interface. Unfortunately, it's not a C, but it's an SMI, Service Mesh Interface. Similar in its kind of genesis and reasoning and what it hopes to bring forth.
Right.
So
question.
I'll say this just real quickly as well. I know, Alex, you brought up Meshery earlier as an open source tool that helps you quickly stand up service meshes and then helps you quickly run performance tests to help illuminate the cost of a mesh.
Cool. Question. I know there was another question out here. Right here.
Hi, Marty. So I just wonder if service mesh is a good option for like event-driven architecture, say if the service relies on PubSub or Kafka.
Per or anyone? Can you ask the question again?
Yeah, I mean, if the architecture relies on events, say if communication is based on Kafka or PubSub, how could service mesh help with that?
So Envoy is continuously improving in terms of what type of protocols it's supporting. So you have from HTTP, gRPCs, but the notion of Kafka and understanding other protocols is continuously increasing. And now with WebAssembly, you will be able to even define more capabilities on top of that. So the idea is that it's not just for HTTP or gRPC, is as time goes and as WebAssembly matures, a set of new plugins are going to emerge. We did some things in VMware with MySQL and some of the data elements of how to start understanding data objects in order to apply policy. Kafka topics is another element that we are looking in terms of applying policies. So all the storage protocols, I see that it's just a matter of time that the mesh will start understanding natively all those capabilities.
And I will add that we specifically did a NUTS filter for Envoy that allowing you to do this with NUTS, but Kafka is coming up and others, so that's something that's just going to happen.
I have a question about security, and I'd like to ask this. You know, what we're seeing with the evolution of container technologies is really this ability to share in a level that we didn't have before, right? There's this portability that is provided with it. Recently, the Docker Hub was attacked, and 190,000 accounts were compromised, and it's raising a lot of questions about the security in the whole entire software supply chain. If you can be able to really pass along these containers so easily. And how do you think about managing that authentication, that identity, when you're in service mesh environments?
I mean, it's not a service mesh problem only. I mean, it's the notion that security has to be tied through all the stages, from the production of the code to the deployment of the code to the runtime of the code. And now a lot of energy is going to the notion of detecting behaviors in the runtime environment, but correlating it to change management or correlating it to new artifacts. And if you detect a behavior that doesn't match what you had in the production of the code or in the deployment, then stop it, put it in quarantine, whatever. But it's this notion that security is going from the notion of saying, oh, a firewall will stop it, or a service mesh will stop it, or whatever it is will stop it, to can I track all the stages of the life cycle of an application and make sure that there's no compromise in any of the stages and be able to correlate across the stages. So there's a lot of effort going on in that direction.
I would actually want to ask a quick question of Cliff. When you were talking earlier, before the panel about what went wrong, not necessarily what went wrong, back in the day when we were thinking about, virtualization and kind of the evolution of virtualization, and what are you seeing as like the parallels that we can learn from today as we're moving forward with service mesh?
Sure. Well, there were a couple of things that we saw happen when virtual machines hit the world, and we saw some vendors take their monolithic code, wrap it in a virtual machine, and say, I'm done, I virtualized it. And then they're wondering, well, why didn't I get any benefits from that? All I saw was a performance hit. And that's something that we don't want to repeat going forward. And one of the ways that we could see it repeated here is that when a vendor produces a piece of production software, what we see bundled in is, for example, what if someone bundled in a service mesh with their code, sent and shipped it? That means now all of a sudden you have another monolithic silo that you have to deal with. We're not able to get any of the benefits of what we look for when we have applications managed as hundreds of small pieces. And it would be very natural for people who haven't changed their culture, changed their thinking, to do that. And so I think that's a danger that we want to avoid. And it's an example of how this might ease something we don't want to see carried over, easily be carried over.
Any questions? There's one right here.
Hey, good morning. I want to ask about the service mesh with the topic of the intercloud one, because our business is running 24 hours and globally, and we don't want to depend on only a single service provider or cloud provider. How service mesh can play a role or solve the problem of the intercloud one? Because actually at the moment it's the pain for our business in order to have it working seamlessly.
In a very simple way, service meshes can facilitate cross-cloud overlays. Maybe that's the most concise way of speaking to that. I think the question about service mesh interface and kind of a standard interface for interacting can also, to the extent that those cloud service providers implement that or are friendly to that specification, that can also help facilitate cross-cloud.
This is one of the areas that we are being asked a lot. We are doing some work and we are introducing some things. We did some announcements even in this KubeCon about federating meshes across multiple clouds. We did some work with Google in Google Next about having a mesh that federates between an on-prem environment and a cloud environment, providing you an end-to-end identity view of the problem and doing service analytics and traffic routing and everything end-to-end. So I think this is the area that it's going to evolve a lot. I mean, if you think in the networking layer, we had, let's say, IP connectivity, but then we had to introduce NAT and firewalls and IPv6 and IPv4 and so on, right? When you go to the service mesh level, now you have identity providers with certificate authorities, and now you're going to have multiple Kubernetes environments or multiple services across multiple clouds. So the question is, how do you federate identity? How do you have a set of policies that if you have services in a public cloud and services in on-prem, you may not want to expose all the services that you have on-prem to the public cloud because you don't want the public cloud to have a full view of what you have in your enterprise. So now it becomes granular control of service mesh federation, understanding what identities are going to be seen and what identities can talk to the other side. So this is what we call kind of global namespaces if you control both meshes, or federation of service meshes if you don't control the other side. But that's an area that it's evolving quite fast because it's a valid use case from an enterprise point of view.
And of interest as well, I mean, for Federation of Service Mesh is if you have an heterogeneous environment, not necessarily only Kubernetes clusters, because you can install a service mesh on also different environments. There's work for Cloud Foundry going on, or for other sort of software. So many enterprises have grown organically, have software grown organically, and it helps bridge and put some common policy over multiple resources. You have some IaaS, some platform as a service, some Kubernetes clusters, and also big something which can really help.
Yeah, and I just wanted to mention that maybe some people in the room aren't sure how widespread the use of hybrid or multi-cloud is, and from our research, on average, we're already getting information from enterprises that they're using 10 different cloud service providers for infrastructure.
Wow.
So that's it's a pretty widespread issue, so thank you for raising that.
Great. Well, on that note, I would like to just thank everyone for attending. Let's give a big hand to the panel here. Florian Dudoué, Cliff Grossner, Edie Levine, Lee Calcout, and Per Monclou. Thank you very much for participating. And I'd like to give a big thank you to VMware again for sponsoring this breakfast. Let's give them a big hand. And thank you all for the excellent questions. And now it's time for the drawing.
Sorry, it's 574414.
574414.
Maybe it's mine.
574414. All right. Oh, we got a winner. Thank you very much for attending. Have a great show, and we'll see you again at another KubeCon. Thank you.
Thanks.
Thank you.
Alex, thank you.
Thank you very much.
Thanks a lot.
Thanks.